All right, we are back for the second part of section 12-3. So you've maybe started your slideshow presentation and pasted in 12-1 vocabulary, 12-2 vocabulary, 12-2 arc addition postulate, and the 12-2 central chords being congruent to the central angles, congruent when the angles are congruent, and that the radius is perpendicular bisector of the chord. When the radius is perpendicular to the chord, then it is a bisector, or when a segment is a perpendicular bisector of a chord, then it is a radius. So those are two postulates that are theorems that are together. And then we've already done from this one, comparing arc length to the measure of arc. And I should probably put in the number, that's 12-3. So now that compares the part of a circumference. So now it's time to talk about part of an area. So I still have these two little blanks that are just came with the template. They're not something I made. The template makes all these different things, but I want to go ahead and make another one that looks like this that I can use for the area. So I can just say slide, duplicate slide, but instead of comparing arc length to measure of arc, I'm going to say, well, comparing, let's go here. Wait a minute. It is the sector of the circle and the area of a segment. So sectors and segments are we're going to talk about. Sectors and segments. So what is the difference? All right, well, sector is easy. It's a piece of pie. So let's go to Geogebra and make a sector. I'm going to go ahead and open a new one, and I'm going to get the area right, make a circle. Okay, I put a couple other points on there. Okay, so my sector would be a piece of the circle, a piece of pie. All right, so circular sector is actually on here. Select center point and then 2 points. So A and then C and then B, and it shows the whole sector. So the area here, this is just a piece of a circle. So if I put together sectors all the way around, I would have a whole circle. So the way I find the area or the measure of this sector, it's an area measurement, so it's going to be two-dimensional. And the way I find that is by figuring out the fraction of a circle I have here. So I need the central angle again. So angle, select 3 points or 2 lines. Well, B, A, C. It's going to go all the way around. The other one works better. I'm sorry. If I go C, A, B, then it'll tell me the inside angle, which I want because that's the shaded area. So 71.5, right? And so, I need to know a radius. I'll go from one of these points to the center, and that will tell me the radius is 3.66. I can calculate the area. The area is pi r squared. So area of A, and I'll call it A because it's circle A, equals pi. Right? I bring up the keyboard using the keyboard thing there, and I find the key, the letter. It's got the ABC open for me right now. There's pi. Times, I can hit the asterisk above the 8, r squared. So r is EA, and here I see distance EA is that calculation. So if I type that in, distance EA, just like I see it here, it will use that number. And then that's to the second power. So the second power, let's see, I think I can tell it here, but here we go, squared. If you want to do it that way, you could also have done the caret, which the circumflex, which is above the 6, and then put the number 2 in there. So now it's calculating the area of the whole circle, pi r squared. So then I wanted to calculate just the fraction of a circle. So really, I just take this number, 42.01, and tell it how much of the circle I want, fraction of the circle. Well, I want 71.5 degrees out of 365. So my sector, and it's BC, sector area BC equals, okay, my original area times the fraction of the circle I want. So the numerator is the central angle of my sector. So here, this alpha, 71.5. So go to my ABC, I can click on alpha and click on alpha. Alpha divided by the whole circle, which is 360 degrees. So that tells me my sector area is 8.34. All right, well, let's go ahead and have the program calculated, okay? Area, select polygon, circle, or conic. Okay, well, let's do this. Area of D, 8.34. Sorry. So it told me already the area of that. Now let's go back and look at our calculation. Sector area BC that we got by taking the area of the whole circle, pi r squared, times the fraction of the circle, 71.5, divided by 360, told us it was 8.34. And when I asked the program to calculate it, it also said 8.34. So it looks like my calculation is working out. And if I move this B, oh, it's not letting me. Oh, I can make it bigger and smaller though. Oh, I see what I did. I haven't clicked on the arrow. All right, now if I move this bigger and smaller, the sector area will change. But as I do, the value here changes, this calculation changes, but these two stay the same. My calculated sector area and then the area that the computer tells me it is. Okay, so I can save this now. I'll go ahead and do it. So I will save it. I'm going to export an image so I can put a blank image, a static image in. So download. And this one is sector area. And it's section 12-3. So I'm going to save that. And then I am going to save it as a GeoGebra sketch. I'm going to call it sector area. And this is actually saving it to my account on the web. If you're not logged in, it might tell you that, hey, that's a problem, log in. But if you log in now, it will share these with other people. Saving has failed. Oh, check again, try again. My computer's network's having trouble. Okay, it'll let me to save it locally. That's nice. But I want to save it so that I can get to the link. So save. And what I want to show you is save successfully, share. So now I can click share and it should bring that link right up. There's the link. Copy. And now I can go ahead and put all this in my in here in my sheets. So I'm going to delete the old one and insert image, upload from computer, find that 12-3 sector area, open it. Now I pretty much always do a little bit of cropping. There it is. I can move this if I want. I need to change this, so I'm going to edit the link because remember I made a copy of the slide before, so it has the old link in there. I delete and do a Control V, and then I'll have the new link in there. Now it'll take me to this. All this old text, it doesn't make any sense. What I do want to have in there, though, is I want to have information on what this is and how you calculate it. So this one right now, I said I was going to compare, but all I've done so far is look at sector. I've looked at sector area. Okay, now I'm going to go ahead and look. Right now, all I've done is The sector of a circle is a region bounded by two radii of a circle and their intercepted arc. And then the equation is the area of the circle, pi r squared, times the fraction of the circle that the sector takes up, which is the central angle divided by 360. Okay. The sector of a circle, this is a piece of pi. Calculate the area by first calculating the whole circle area, then multiplying the area of the circle by the fraction of the sector, which is the sector's central angle divided by 360 degrees. Oh, I can even put that special character in and do degree. It will come up. I click on it and it has a fancy degree signal in there, and I fix the link and there we go. That's the segment. I'll make one more short video. I might even make that, crop that just a little bit more so I can make it a little bit bigger. All right, and now I said I was gonna compare segments, but I'm not going to. I'm gonna say instead that this is the sector of a circle. I'm going to stop this video here and go right to the segment of a circle, the third piece inside 12-3.